Hey everyone, we've just released version 0.3.0 of Lula. In this release, we kind of focused on a lot of development workflows around the validations themselves, and then from there, kind of augmenting how we even get started with the kind of core dependency to Lula, right now being the component definition. So we have this generate functionality that can get you basically on the road to get started with generating artifacts to be used for your various software components or for your systems. And then from there, injecting these composition workflows so that you can compose a component definition with a variety of external resources. And then from there, when you need to ultimately make them most portable, especially with regards to environments where you may not have the connectivity to go and retrieve the reference artifact, you can go and compose the artifact into one single portable artifact that you can take to your environments. So with that, I thought I would walk through a couple demos with regards to what this release includes. So in particular, we have a Lula-dev command that was released in a previous release. It has a couple commands that allow you to work with a validation. Here's a validation, for instance, that you can see. So if we are connected to a cluster that has pods, we have a target for running our assessments against. With Lula, if you don't want to worry about the OSCAL in your development workflows, Lula-dev is really meant to handle those. And so we can pass in, for instance, a validation by itself so that you can just focus on one key piece of validation, perform that validation and get feedback quickly. That's kind of great. Another point to this is like, how does somebody know how provenient the validation that you wrote really is, that it works correctly and that it does what it's supposed to? So with Lula-dev, we have get resources, and when that is given a validation, it's going to read these resources and simply output the resources involved. So we'll call that resources.json. So we have a new file. It's the resources that were retrieved. This is ultimately the data you're using during validation. And what's nice about this is you have this key piece of data that you're using for validation. And so now we can essentially go offline with Lula-dev validate. We can say we want to continue to use that same validation, but now we can pass in our resources file. So this actually won't connect to any live environment. It'll use this data, and you can use that for even quicker feedback. You can use it in pipelines for validating that something works correctly. So in this instance, we pass it in. You see that you get the same results that you had against the live environment. Makes a lot of sense. Based upon what this validation is doing, checking for this label, if we modify this label to become invalid in this resources and reran this, you're going to see it error out, and that's to be expected. So this kind of is part of the development workflows that we're really looking to continue to build upon. You'll see more improvements in this space, probably likely in the near future, because it's a high point of interest for how are we going to develop validations. It's a very in-depth and tedious process. We want to make it better. We want to make it faster, and figure out how to ultimately make the developer experience better. With that, we can move on to some of the other big advancements that Lula has made. One of these being the Lula generate command. Right now, it only supports the ability to generate components, i.e. component definitions for OSCAL models. The goal here is to continue to iterate on that and build out assessment plans, to build out system security plans, to build out POAMs, to continue to build out how you generate these artifacts and get you from 0 to, say, 50% in a automated fashion. So with that, what we can do is we can generate a component. What this looks like is a little in depth as far as your requirements are concerned. We have this Lula generate component command here. It requires a source catalog. Where are you pulling your controls from? Which controls do you want to include from that catalog? So a little bit of innate knowledge required. What do you want to name your component? Software component A in this instance. And then I'm giving it a file to output. And so I'll run that command. You'll see that I have a new file here, component.a.yaml. This is a component definition. This is the thing that you need to feed Lula in order to do validations. The only missing component here is, now that you have this, you need to write your validations. And so given that we have this validation that we were working on in isolation, we can basically take that and reference it via the links that we used previously that went straight to the back matter, and we can reference a file directly. So validation YAML. No more copy paste errors while you're doing your development workflows. You can reference a file directly, remote or local, and be able to operate on it. And so this UUID here matches a UUID within this validation. And so if we wanted to, again, Lula validate, the proper Lula validate command allows for taking in that. We can run against it, and you can see in, for instance here, a quick look, satisfied is relating to the UUID associated with this finding. How you map that is through the assessment results, and that's not something we're going to cover in this instance, but you can see that you can now use this and separate files for your development workflows in order to build out these OSCAL component files. So that's great. But when we think about how we want to get these documents to a specific environment, we're going to have to incur the disconnected nature of, we might not have direct access to that validation.yaml file for one reason or another. So in the tools command for Lula, we've now added this compose command that allows us to perform the composition of component definitions in such a fashion where if we run Lula tools compose and then pass in a component definition, which is in this instance component A, and then we output whatever we want to call this out. We'll say compose A. It'll create a file for us. What will change here is the links that we previously had they do not point to a external file. Now they point to a reference in the back matter as OSCAL is intended to be used for where this validation can now live. And so you can do all your validation development in isolation. You can write them in separate files. You can reference them directly via those separate files. And then when you're ready to ultimately promote or take that file to an environment that won't have connectivity to all those disparate files, you can run compose and you'll have one single artifact that, just as before, we can run Lula validate and say compose A as our input. And it will output a file here. Small error with regards to writing the component. But if we run that, you can see, hey, no issues, still satisfied. So that represents one layer composition. The other layer composition that we kind of focused on was what happens when you want to create component definitions that import other component definitions. This is going to be another big focus for us here in the near future. For sake of providing a layer where you could override a control from a different source, a component definition that exists from some authorizing or authoring body for that. And so in this instance, we'll do another local generation as we did before. In this one, we're going to say, here's a new software component B. We're going to put it in the comp B YAML file. So we'll generate a whole new component definition. Awesome. It's a separate component. These are two separate components from each other. Maybe in this instance, two separate software components as part of a greater system. But let's say I want to include B in A for sake of, again, composing those files so I don't have to take multiple component definitions over to an environment for whatever purposes that I'm doing. And so in my component A, the component definition model includes an import component definitions. I can use a reference here to a local file. This is component b.yaml, which we just generated. This file, again, as you recall, still contains like these validations. And so this sets the stage for like how you do all of your development of this compliance information in a space where you can have all the resources you need. And then when you are ready to take them elsewhere, it allows you to coalesce all the data into one specific artifact. And so what we'll do is rerun compose. We'll call this a compose both file. This will be both the external validation that we have as well as an external component definition to be imported. We run that. You can see compose both is now created. It has the back matter item for our external validation as we've seen previously. It has a software component B component here. If we minimize that, we also have software component A, which was the original. So now we have a single artifact, all of our validations local, all of our component definitions local. And this is really just step one of many other improvements that we're looking to make with regards to how we want to establish the composition of many OSCOP models. This will be a continued process that we see across all of the models as we look to develop them. And so with that, that's all the updates for this release. There are other bug fixes included as well as dependency updates. Please check them out. If you have any issues, please file those issues against the Lula repository or check us out on the Lula-dev Kubernetes Slack. Thanks all.